Everybody, it is Mrs. Bazicki here, and I am going to read to you the element, compound, and mixture notes today. Let's start with a chart. So, if we look at this chart, we're going to notice that the top of the chart talks about matter, right? So everything in the universe that has mass and volume is considered matter. So matter is pretty much everything. You're matter, I'm matter, the tables matter, the air is matter, your pee is matter, right? You can make it be hilarious all the time. But matter is anything that takes up space and has mass, okay? Now, all matter in the universe can be separated into two major categories. You have a mixture and you have a pure substance, right? Let's start with pure substances. Pure substances can then be separated into elements and compounds, right? Elements are what we find on our periodic table. Okay? Compounds are two or more elements that are chemically combined. And we'll go more into detail about that in a minute. On the mixture side, there are two options. Mixtures can be homogeneous, which means that they are evenly mixed throughout. Homogeneous mixtures cannot be picked apart very easily, and they look like one substance. And I'll show you some examples. And then heterogeneous or heterogeneous mixtures are mixtures that are different throughout, meaning they're not evenly mixed, and it's pretty easy to pick them apart, their individual pieces. These root words, homo and hetero, are used a lot in science, a lot in biology as well. Homo meaning the same and hetero meaning different. So keep that in mind as you take biology next year. You might hear those words again. All right. Let's start with mixture. So mixture in general is a combination of substances which keep their properties. So mixtures maintain the same properties they already had even when they're mixed together. Examples would be air. Air is actually a mixture because there's a ton of stuff in there. Salt water, sterling silver, and 14 karat gold. So 14 karat gold is actually a mixture. It's not a pure substance. Right? 24 karat gold is pure, but not 14. We'll get into that in a minute. Right? So homogeneous or homogeneous mixtures are the same throughout the mixture. What that means is that when you look at something like milk, it looks the same. If you take a spoonful of milk and then take another spoonful of milk, those two spoonfuls should look identical. Same thing with Kool-Aid. Same thing with, your spoons here and your knives, right? Stainless steel is actually a mixture, but to us it looks like one substance because it's so uniform. It's so evenly mixed. It's perfect, right? So again, examples: milk, Kool-Aid. Yeah, the Kool-Aid man. Gotta love that guy. 14 karat gold, again, is actually a mixture of gold, silver, and copper. It's not pure gold. And the reason they actually do that is because it actually makes the gold stronger. Kind of neat, right? And then these two words down here are really just showing you a solution is a substance that's dissolved in another. So like Kool-Aid, coffee, salt water, sugar water are all solutions. And then alloys are actually metals of mixtures. So if you've ever heard the term alloy, especially if you're like into cars and stuff like that, you might have heard that word, or if you work with metal. But it's basically a mixture of metals. So sterling silver, stainless steel. These are all things that they mix metals together because, again, it makes it stronger. So the original metals are not as strong as the completed mixture of metals, which is kind of cool. Right? Heterogeneous or heterogeneous mixtures have parts with different properties. So these are different throughout. Every handful, every bite, every scoop, every sample is going to be slightly different. Right? I love to use food as examples, right? Food is life. So we've got M&Ms, and so same thing. M&Ms are one of those things where, like, if you grab a handful over here, you're going to have a bunch of greens. If you grab a handful over here, you're going to have no greens. Right? Heterogeneous. Heterogeneous. Taco, same deal, right? If you take a bite from the bottom of this taco, you're going to get all meat. If you take a bite from the top, you're going to get all veggies and cheese. You got to take that bite right in the middle, right, to kind of get some evenness there. And then Fruit Loops, same deal. Pizza, all right? Love pizza. It's like my favorite thing. So those are mixtures, and now we're going to talk about pure substances. So pure substances are matter with uniform and unchanging composition, right? This is very important. They are not only uniform, which means they're the same, right? And think about uniform, if you're in ROTC, right? You guys wear uniforms, so you look the same. The word uniform literally means the same, right? One form, uniform. And unchanging composition. So things like helium, sugar, and 24 karat gold are pure because they are always the same. Sugar from everywhere in the world is the same sugar. Okay. Gold, 24 karat gold, no matter where it comes from, is the same. Helium, same deal. Okay. So elements, and I'm sorry, this is like really annoying, this little writing here, but I'll fix that. Are pure substances that cannot be separated into simpler substances by physical or chemical means. Elements are found on the periodic table, okay? There are 92 naturally occurring elements. All the other ones that you see on the table are actually man-made, which is really cool. And actually, if you go to the K-12 periodic table app, it will tell you which ones are man-made. Some examples here: aluminum, carbon, bromine, gold, all right? So these are things that are elements. They're the purest of the pure. You can't separate them, can't change them. They just exist. Compounds, on the other hand, are actually two or more elements chemically combined so that the properties are different than the elements that are there. So what you're doing is you're taking two or more elements and you're combining them chemically, but that combination stays the same always, right? And so what I mean by that is, like, if you have something like, I don't know why I can't see the bottom of this, H2O is water, always. No matter what, no matter where your water comes from, what it's doing, water is H2O. If you do something like carbon dioxide, it's CO2, always the same formula. Salt is NaCl, always the same formula. And even those little numbers have to be the same as well. Okay, so I hope you enjoyed learning about some of these different elements, compounds, and mixtures. And if you have any questions or concerns, please make sure to email either myself or Mr. Bazicki. Hope you guys have a great rest of the day.